Hello everyone, welcome to Clashing Coder. So in this video we will see the question number 238, product of array except self. So this is a medium level question and it is one of the most questions on LeetCode. So let's see the problem statement. Given an array numbers of n integers where n is greater than 1, that means we will be given at least more than one number, that will be 2, 3, 4 and so on. Return an array output such that output I is equal to the product of all elements of numbers except the numbers of I. So that means that you can see from the title also that product of array except self. So that means we have to find the product of all elements except the element that we are on or the current index we are on. So for 1, what will be the output? So you can see we have to find the product of all elements except 1, because it is written that product of all elements except the numbers of I. At ith index, that is 0 index, the product of all elements except this will be 2 into 3, so that will be 6 into 4, so that will be 24. So you can see answer is 24. And for the second index or the first index, you can see it will be 1 into 3 into 4, that will be 12. Similarly for 3, it will be at this second index it will be 1 into 2 into 4, that will be 8. So similarly you can find the output array. So we are given the constraint that it is granted that the product of elements of any prefix or suffix of the array fits in 32-bit integer. So we don't have any space this error. So let's see the note. So please solve it without division operation or without division and in O of n time. And there is also a follow-up question which we will also see. So could you solve it without or with constant space complexity? And it is written that output array does not count as this space complexity. So let's see how we can solve this. So basically you can think of the naive approach for solving this question. First, the basic approach that can be simply you can start a loop that is using two nested loops. So you can start a loop from 0 to n, and I will run from 0 to n, and j will also run from 0 to n, and you will calculate the product of that value. You will initialize the product variable or the int variable in the first before the second for loop, and what we will do is you will calculate the product of all elements except for the I if I is not equal to j. If I is not equal to j, then you will calculate the product of the element with the current element. So this is how you can use the basic approach, that will be naive approach using the two for loops, but this will take O of n square time. So this is not a good solution. So you can, if you are asked this question in interview, you can simply tell him the basic approach. Then what can you do is you can simply optimize the solution. What we'll do is there it was written that we have to not use the without the division operation. So but for if we want to use division operation, like in an interview he won't mention that you don't have to use division operation until you tell him that you are using this. So what will we do is we can simply calculate the product of whole array and save into a variable. So we will name a product variable, initialize a product variable, then calculate the product of all the elements of the array. So it will be 1 into 2 into 3 into 4, that will be 24. So 24 will be the product of the array. So it will take O of n time to calculate this because we are traversing over the array. Then what we'll do is we will initialize the result array, and we will traverse over the result array and what we'll do is we have the product variable and we have the element at that index. So we can simply divide this element by that element, so that will exclude the 1. So 24 divided by 1 will be 24. So 24. So 24 divided by 2 will be 12. So you can see we are simply dividing this element out of this. As we multiply it, we are removing it by dividing it. So this will result into our result array that we are finding for. You can see 24 divided by 3 will be 8, and so on, this will be 6. So you can see we have got our output array simply by using this. But this will also you will also have to take care of the division by 0 conditions, because you can see maybe there occurs a 0 over here or something, like you have got the input as 0 and 0. So then you will get an error because division by 0 error. So that you should check for the boundary condition using simple if else statements. So you can do that. So but this was the basic solution actually, but you can see it will take only O of n time and O of n time and constant space. You can see because we are simply maintaining a simple variable, as the output array does not count as extra space, so space complexity is also constant, and the time complexity is O of n because we are traversing the array only one time, and basically 2 of n because we are traversing the first time before calculating this product and second time for calculating the result array. So this was the one approach, but as it is directly mentioned into the question that we have to solve it without using division operator. So how can we solve this using without division operator? So let's see. So the basic approach for solving it without using the division operator will be simply calculating the left and the right arrays. And what will be the left and right array? So it will be the cumulative sum from the left side, and right array will be sum from product from right side. So how we will calculate that? So it is actually a pre-computation we do for finding the sum between the ranges also, that you have to find the sum between 0 to 2. So we also pre-compute the arrays for that. So that is the concept that we are going to use. So I have written the pseudocode also. So first of all, we have to find the left and the right pre-computed or the cumulative arrays. So how we can find that? Let's see. So first of all, it will be first element will be same, because we are starting from the left. For left we have to start from left, and right we have to start from right. So let's see. So this is our array, these are the indices. For left, first index will be equal to the 1 only, because that is 1. So now what we will do is we will multiply the L minus left of I minus 1, that will be this 1, into the array of I, so that will be 2. So here the product will be this 2 into this 3, so it will be 6. So now for 4 and 6 it will be 24. So you can see we calculated this array using the left to right traversal, that is pre-computing this like you can see all the we have pre-computed the values. So now we are calculating for the right array. So it will be, you have to start from right, so right index will be same, because we have not multiplied any value from right. So actually it was multiplying the values from the left to this current value, and it is multiplying all the values from the right to the current value. So now this is the current value 6, and multiplied by the values before that, so it will be 4. So either here it will come 24, you can see. So now if, sorry, not 24, actually it is this array, this is a left array, so it will be 12. So 12. Now you can see 2 into 12, so it will be 24. 1 into 24, so it will be again 24. So this is our right array, and this is our left array. So let's just cross check if it is right. 4 and 3 12, and 2 and 24, okay, and see, okay, it seems to be correct. So this is what we have done. So we have simply calculated the left and the right cumulative arrays, or you can say pre-computed arrays. So now for every index, you can see for every index, if we are finding the output for this index, what is our output? So actually it is the product of all the elements on the left of it and all the elements on the right of this. So you can see it is a product of all the elements on left and all the elements on right, and we have simply pre-computed these products. So for this index, actually if we are calculating for this index, what will be the product? So you can see we have calculated the left product, it will be 1. So you can see 1 multiply by, now what will be the product from this side? It will be, you can see from right array, it will be 12. So it will be 12 into 1, which will be 12. So you can see here it will come 12, and let's cross check if our element is 12. Yes, you can see our output is also 12. So this is the basic approach that we will use. So let's see how we can calculate this. So you can also read the pseudocode from here. So now we have to traverse the arrays. So our current result, so the base condition will be, actually you can see here we will have base condition also. So for the first index, the product will be simply the left value or the array value only, because from here the value will be right array, the right arrays for that index, because you can see there is no element on the left side of 1. So it is a starting index, so we have to calculate the product of the ending or the elements after 1 or this index. So that will be simply given by this result array, so this right array. So it will be 24. So let me write it actually. So it will be 24 if you see, because we know that all the elements before 1, there are no elements before 1, actually 0th index. So we have to calculate the product of the elements after this 0th index. So it will be given by our this right array, so it will be simply 24. So you can see we have written 24 here. So this is the base condition that you can initialize. Now we have to start traversing from the first index, so we have to start traversing from this index. For this element, you can see for 2, what will be the output? So you can see all the elements before 2, the product of all the elements before 2, which will be given by this left of I. This is our I. So left of I minus 1, so that will be 1. 1 multiplied by left of I plus right of I plus 1, because we have to find the product of these elements 3 and 4. It will be given by our right array, so it will be 12. So 12 into 1 will be, again sorry, I'm doing something wrong actually, let me check. So it will be, okay, 1 minus, sorry, this was our array, okay, 1 into 12. So it will be simply, let me write it, 12. So you can see 12. So now for this index, what will be our result? So you can see this is our I is at this index. I is our 2 index. So now what we'll do, we will calculate the product of the left elements and the right elements of that index. So what, how we will find that? So simply left of I minus 1, which will be this index 2 multiply by right of I plus 1, which will be 4. So 2 into 4, it will be 8. So you can see our output is also 8. So now for this index, this is also base condition actually, because we have to find the product of all elements on the left side, because this is the last index, so there won't be any elements on the right side. So we have to find the product of only left side elements. So that will be simply given by this 6. So you can see it will be actually, let me write it like this. So you can see I've written also here. So a result of 0 will be always equal to the result of right side, this 0, and the result of n minus 1 will be equal to n minus 1 is this index, will be equal to the index before it. So that will be n minus 2. So you can see left of n minus 2. So our output will be 6 here. N minus 2 is 6. So you can see, I hope you understood this actually example I told you. So now what will be the time complexity for it? So actually time complexity will be O of n, because we are only traversing the array, and we are like actually it will be 3 of n, but it will be considered as O of n only, because we are computing the left array, then right array, and the result array. And the space complexity will actually increase. In this solution we use only constant space, but here the space will increase to also O of n, because we are using 2 arrays to save. It will actually 2 of n, but we will consider it as n only, because it is approximate value. So I hope you understood this solution. Actually I don't like think you need the code for this. You can simply code it and you can find the value. So I have written the pseudocode also, you can understand how we found the value. So actually for the quick recap, let's see, for let's actually explain you again this basic thing. So actually for finding the if you want to find the value at this index, what will be its value? So it will be the value of the product of the elements before this index. At this index we are finding the value, and the index after that. So how we will get that values? We have actually pre-computed the values in the left array and the right array. So what we'll do is we will simply take this value before that index, and after that index we will take the right array's value, that will be 4. So 24 will be 8. So you can see we have simply got the value, that is 8. So I hope you got this solution. But now you can see we solved this solution without using the division operator and in O of 1. That is correct. But now there will be a follow-up question. Could you solve it using without using it constant space complexity? So that means we have no chance like we have no chance using this left and right array, because they will increase our space complexity to O of n. So let's see how we can optimize this solution further. So let's see. So this is our pseudocode. Actually I've written the pseudocode again. In this array, the simple like optimization will be to compute the left array in this result array only, output array that we are going to use. We will compute the left array in this result array only directly. So what will be the left array? So it will be similar to this. Let's again try. So array of 1, it will be 1, left of 0 will be equal to right of 0. So now we will start traversing from this array. So it will be 1 into 2, it will be 2. 2 into 3, it will be 6. 6 into 4, it will be 24. So we have computed our left array in the result array only. So now without using it, because we know that result array does not count as extra space as it is given in the question. So it now up till now we have done this thing in O of 1 space complexity, where instead we were using O of n space. So let's see. So now what we will do is we will simply create a right variable. So you can see we will create a right variable, and now let's see the pseudocode again. So I have computed this array into the result array. Now we have to initialize the right as 1. Okay, we have to initialize the right variable and as 1. So basically what we will do is we will simply like compact this right array into a simple variable, that is using the right. We will calculate all the values. So let's see. So what will be the first, our last, we will have to traverse from starting from the last index. So we will traverse in this direction. In previous we were traversing from left to right, now we have to traverse from right to left, because we have to use this right variable, and without using the right array we have to calculate this. So let's see. So first this value will be equal to, what will be this value equal to? You can see this value is always equal to the product of all the values on the left side excluding this value. So what will be it? 1 into 3 into 2, which we have calculated in this right array only, this result array only, that is left computation. You can see it will be 6. So we can simply cancel this value and make it as 6. So let's like simply erase this. So we can simply set this value to 6. Okay, so you can see we have set this value into 6, and now at every index, as we are traversing from right to left, what we have to do is we have set this value, so we will start from this index actually. So now we have to multiply this value, that is 3, into our right variable, because we have to find the right value also. So now first the right was 1, because we were not having any element over here. We cannot take it as 0 because it will make the product as 0. First, if we have to find sum, then we can take it 1, but now we have to take it as 0. Actually now we have to take it as 1, so we will simply multiply it with the value. Now our I is at this index, so I is at this index. Now for this index, what will be the value? So actually it will be the product of the left elements and the product of the right elements except this index. So we have found the product of the left elements. It is stored in the result array only, so it will be 2. So you can see 2 multiply the right array product, so it will be actually 3. You can see 3 because we have to consider this array. So you can see 3. We have found the right array, so it will be 2 into 3. It will be 6. So okay, actually this 2 into 4, sorry, I took the indexes, sorry for that. I hope you understood what I'm doing now, so mistakes happen. So you can see what will be the product for what will the output out for this index. So it will be actually the product of the left elements, which are 2, and the product of this element also, that is right. So right is actually 1 to 4, it will be 4. So 2 into 4 will be 8. So here the value will be first 6, then it will be 8. Now we have to find 2 values more, so let's see. Okay, so actually we don't know what is happening. So actually now we are at this index, that is 1. So what will be the value? So actually when we go the one index behind, we have to multiply the value of that index or that array into the result array, this variable, because we don't have any result array, so we have to keep the count of this in the result, this right variable actually. So now let's see. So at this index the value will be equal to the left product into the right variable, so it will be 1 into 12, so it will be 12. So you can see 12. Now I is at our I is at this index. Now our I is at this index, so let's see. So now the product of the this index will be equal to the result array. The value will be equal to the product of the right elements, because there are no left elements left. So what we will do, so we have already calculated the values for the actually when we move to this index. So okay, we forgot to update, so we will update at every index. We will update this to 24 now, so it will be updated to, like for example, our I right is at here. So first our right is equal to 1 at this index. Now when we calculate value for this index, now before decrementing our right to this index, what we'll do is we will simply multiply the array value at that index to the right, so it will become 4. Okay, so it will become 4. Now when we calculate the value at this index and our array index is coming here, then we will multiply the array value of this index into the right variable, so it will become 4 into 3, it will be 12. So that's how we are calculating this. Now at final we will, as we have a right value as 24, so we will simply update it to 24. So now you can see we have got our array, and also we took only O of n time, because we are traversing the array and then linearly, and we are only using a right variable, as output array does not count as a extra space, so we have done it in O of 1 space. So let's see the code actually. So this is our code. Actually I have written the code in C++, so you can see. So this is our code. So actually what we'll do is we will simply take the count of the length of the array, then I have initialized the result vector or the variable the array. Then simply we know that base condition, that the result of 0 will be always equal to the numbers of 0. So we have done that. Now what we'll do is we will simply calculate pre-compute this left array. So you know we have to compute this left array into the result array, so we are directly computing it into the result array. You can see, so it will be simply computed by the previous result, which was this, which will be in this, you can see previous result, that is 1, multiply the current index value, that will be numbers of I. So it can be simply computed by that. Now what we'll do is we will simply initialize or set this last value into last value before was 24, and we have to set it to 6 directly. Cut this and set it to 6, because we have to find the product of the left elements except this, so this should not be included. So you can simply set it to result of n-1 is equal to result of n-2. So then set initialize this right variable that we will be using. Now traverse for the whole array from the right side n-1 while I is greater than 0, I minus. So then what we will do is result of I will be equal to result of I minus 1 at this value and the right variable which we have calculated, right variable. So that is what we are doing. Because we have computed the left array in the result only, so we will simply use I minus 1. So then after doing this step or calculating this, as I told you, don't forget to multiply or discount this right variable or update this right variable, because we have to multiply this element also into the right variable when we are decrementing the index. So that is what we are doing, and the result of 0 will be equal to the result of r. You can see that it is easy. So let's run this. So I hope you understood the question. Actually I tried to approach all the show all the approaches which we can use. So let's see. So you can see it ran like faster than 50% of session. Let's submit it again. Maybe it runs faster. So it only takes O of one space. You can see. So yeah, you can see it ran faster than 95.65% of session, and it took less memory than 48.07% of session. So I hope you like this video, and I will share the code in the description section so you can refer the code from there. So do like this video and subscribe this channel. Thank you for watching, guys.